So total formula for the total utilization factor is PDC over VS IS. Plugging in the values that we have previously calculated for PDC. Now we have VS as well, which is 0.707 VM, and IS as well. So using those values, we found out the value of TUF, which comes out to be 0.286. Now determine the peak inverse value. A peak inverse value is the maximum value that appear across the diode when it is reversed biased. Therefore, whatever the value of this VM, this VM or the voltage VS supplied over here, when will be that will be the value of the peak inverse value of the diode. In the positive half cycle, this positive terminal will be connected over here and the negative will come over here. But in case of negative half cycle, the polarities will be reversed, and this diode will be in open circuit or reverse bias condition. So the diode should have this much peak inverse voltage, that it does not go into breakdown region by the application of this much voltage in the reverse direction. So peak inverse voltage is equal to Vm in this case. Similarly, now finding the crest factor, IS peak can be calculated as Vm maximum value over R, and we have the RMS value as 0.5 Vm over R. The ratio of these both will turn out to be CF is equal to 2. Now power factor is equal to cos phi. It can be calculated as power AC over VA rating of the transformer. So plugging in the values of PAC and the VA rating of the transformer, so the power factor comes out to be 0.707. Now we have to summarize this example. So the ripple factor we calculated was 121%, which is very high. The efficiency was turns out to be 40.5%, which is very low. In case of full wave rectifier, I will see that this efficiency will increase, and the total utilization factor is 0.286, which is very low, and the inverse of this total transformer utilization factor is 3.496. This value signifies that the transformer must be 3.496 times larger than when using a pure AC voltage source.